Functions. At its simplest, they're just tools to help you keep your code organized, right? Because essentially, if you have your code in a function, you could reuse it, you can refer to it by name and things are very clear. This is the simplest use of functions in programming. But as it turns out, there are more things you can do. And today, we'll explore a sort of a class of functions called higher order functions. How these work are very interesting, and perhaps at first glance, not all that apparent. So today, let's take out some time to talk about it. You're watching another Random Wednesday episode on 0612 TV. Hello and welcome back to another Random Wednesday episode. Today, let's talk about higher order functions. Now, here's the definition of a higher order function. It is essentially a function that takes in a function as an input and or produces a function as the output. That's the idea, right? So the rest of our functions are called first order functions. A first order function simply takes in some data, produces some data, right? That's all. It only works with data. A higher order function would work with functions. So yeah, as you can imagine, it's a function that takes in a function, does something to it, and potentially also produces a function. Your first thought may be, why? Why do we want to do this? And sure, it's really not needed if you just want to do basic things, but as it turns out, it could produce some advantages in some contexts. So what we're going to do is today, we're going to take a look at some examples and some applications of higher order functions in action. So yeah, without further ado, let's jump right in. Let us start with the simplest and I think most common way in which you would use higher order functions. And that is, well, we have a function. It takes in some data as well as a function. And that function will be called to help you do something on that data. Let's take a look at several examples of this, starting with the simplest of all, which is map. Here's the deal. Essentially, map just runs a function multiple times on a set of data items. So if you give map n items and a function f, f will be run on each of the n items, producing an output list that is also n items long. That's it. That is the simplest higher order function. Now, here's the deal. You might be thinking, well, I could do that in a loop. And yes, you would be correct. You could indeed do that just using a loop, right? Running the values and building a list as you go along. But depending on what programming language you're using, there may be some advantages to using map. For example, I just showed you that demo in Python, and when it comes to Python, because you're not explicitly creating a loop, it is actually faster to do map than to use a loop. Moving on, let's take a look at a higher order function called filter. Same idea, we give it a function f and a list of n items. This time, however, the output could be shorter or could be n items. The function is called on each item that you have, and well, your function needs to give true or false at the end of the day, a Boolean value. If it's true, we keep the item. If it's false, it is filtered out. Again, you could do this in a loop, but there are advantages to using filter like this. So yeah, that's the idea. Give it a list of items, give it a formula to figure out what to keep and what to lose, and at the end of the day, you get a filtered down list. Simple as that. That is also a higher order function. Moving on again, we have reduce. Yet again, exact same idea. We give it a function, we give it a list. Now, the interesting thing is, in this case, your output is almost always just one item. You see, what reduce does is, it takes the list of items you have, and it performs the function again and again to reduce the items down to just one. So the simplest example of this in action would be a summation operation. You have a list, you want to get a sum of each item, so the function you give to reduce would simply be a function that tells you how to combine the items together. Generally, how reduce is done is your function visits each one of the items and it accumulates an answer as we go along. For each item we visit, essentially the function takes the accumulated value, it takes the next new value, and it does some operation to produce a new accumulated value. That's the idea, and this is what it looks like in a tree form. Regardless, at the end of the day, we reduce our list down to just one item. Let's move on again to sorting. Now, This one is particularly interesting because while the overall higher order function, the format looks kind of similar, the function you pass in is again different. Essentially, well, most sorting algorithms are comparison in nature, and what you need to specify in your function is how two items actually compare against each other. Now, in some cases, this would be redundant. If I had a list of numbers, it's obvious how you would sort them. But what if I had a list of custom objects? These are, complicated data structures, there are a lot of things in them. You have to decide how two objects compare up against each other. That's why you need to write a function to essentially teach your programming language how two items compare. So again, your programming language does whatever sorting algorithm it likes, as long as it's a comparison-based algorithm. Every time it performs a comparison, it will run your function, so it knows which item is smaller, which item is larger. Now, interestingly, the 4 higher order functions we've just looked at have their equivalents in parallel programming. And, well, this shouldn't come too much as a surprise. When it comes to parallel programming, you have a bunch of items. What you have to do is you have to specify how to deal with one item. And essentially what your device actually does is it takes that same logic and it just applies it to multiple elements at once. Again, at its simplest, all you do is a map. You take that function, you run it on all the items, at the end of the day, well, the items would have been transformed. When it comes to things like filter and reduce in parallel, there are certain strategies you have to take. For example, when it comes to reduce, instead of just taking a value and accumulating it as you go along, you can't do that in parallel because that's inherently serial. Instead, reduction will work on small groups of elements. For example, if I have this grid of numbers, we could run a parallel process for each 4 values. For each 4 values, we will combine them to 1, and essentially we will have reduced the size of our list. We will then repeatedly do this until we compact all values down to just 1 value, and that's your answer at the end of the day. So there you go. Those were your 4 most basic higher order functions. Now, let's very quickly take a look at another kind of subtly higher order function, and that is a function that makes use of a callback. If you do web programming, if you do JavaScript, you'll see this a lot. Essentially, we have a function that does something. Now, there could be a possibility in which this particular thing takes way too long to actually run, to actually complete and give you a result. And when it comes to JavaScript, because everything is run in a single thread, doing that basically halts all processing, and you don't want that to happen. So instead, when you call that function, it spawns its own thread and does that thing in the background. In order to get the results back at the end of the day whenever it's done, you give it functions. You give it what is known as a callback function. When all that computation is done, it will call your function and it will give the result to you via that function. This then allows you to handle the result coming back to you, right? So yeah, you definitely need to do something like that because again, it's in a separate thread, so you wouldn't know when it finishes. An additional advantage this also confers is the fact that you could give it multiple functions. Say a function to handle the success case, a function to handle the error case, right? And depending on what happens, only one of these functions are called. So not only do you have the ability to defer a function call, you also have the ability to selectively make a function call. So it's very, very useful. So those were the most basic higher order functions. We've only looked at half of the definition at this point, which is, well, you give a function to a function, right? We have not talked about the part in which a function comes back. So let's take a look at that, which I feel is a more complex application. Essentially, we are entering the territory of having a function take in functions and modify them. The simplest way of doing this would be composition. One very common example of this would be a twice function. Essentially, you give it a function and a value to execute it on, and what it does is, as part of this higher order function, it calls that function twice. So we're getting there now, but we still haven't done that very important thing, where your function actually gives you back a function. Well, technically, you could for something like twice. Instead of returning the result directly, we build a function and return that function. So while we've sort of seen everything I wanted to show you, I do want to show you just one more example. One more that is, I guess, more grounded, more real world, practically usable one. And let's do a remapper function. Here's the deal. Let's say you're writing a program that deals with a lot of numbers and you have a bunch of functions, right? These functions will, given a range of inputs, give you a range of outputs. But what if you wanted to programmatically build new functions that have the same, functionality, but the answers are remapped to a different range? Sure, you could write just, a simple remapper on its own and just recalculate the values. But what if I wanted to bake it in to a brand new function that does remapping? Well, as it turns out, we could use a higher order function to build a brand new function that gives you the results in the range you want. And the best part is we can programmatically tweak up those ranges so we can dynamically build new functions as and when we want. Hopefully this sounds cool to you. Let's see how we can build this. Let's now build a simple remapper function, which first takes in a function and then it takes in 4 numbers. The original range, that is the range of outputs of the original function, and the new range, the range of values you actually want the function to have. You can stick these 4 numbers into a formula and it will basically tell you how you can change up your original function so that it gives you values in the new range. We can then use these 4 numbers to build our new function. We essentially return a brand new function that calls the original function but does some math to the answer before we return it. So now we can call our remapper function. We can give it our original function and the ranges of values. And this gives us a remapped version of that function. Now, all we need to do is to simply call that function anytime we want, and it will give us values in the new range. We have essentially written a function that builds new functions for us. And that, ladies and gentlemen, is why higher order functions can be so powerful. And all this is despite being a completely optional feature. I mean, you don't even have to use functions at all in your code, much less higher order functions. But if you want to use it, it can help you express yourself so much easier and can give you so much more power. So yeah, that has been higher order functions. That's all there is for this episode. Thank you very much for watching. I hope you've gained some insight today. But until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.